Number 12 says, a rate of which water flows out of a pipe is given by a differentiable function r of time t. The table below records the rate of 4 hours intervals for a 24-hour period. Use the right rectangular approximation method with 6 subdivision. That means you're going to have 6 rectangles of equal length to approximate the square root, the integral from 0 to 24 of rt dt, and display the meaning in the answers in terms of water flow. So what you're going to do is just, easiest thing to do is sketch it so you can kind of know what it's going to look like. When x is 0, y is 9.6. When x is 4, we're at 10.3. So this is what my sketch would look like. So what we're going to use right rectangular. So that means that the right is going to touch the graph. So this means find the area under the curve from 0 to 24. So the area of my first rectangle, each of them have a base of 4. Okay, so we don't have to worry about that. So what I'm going to do is I'm just going to multiply the 4 at the end, because it's base times height, and everybody's base is 4. So the height of the first rectangle is 10.3, the height of the second, 10.9, the third, okay, so the first rectangle is 10.3, second one is 10.9, 11.11, third one, fourth one 10.9, the fifth one 10.5, and the sixth one is 9.6. Remember, each of them have a base of 4. So you're just kind of multiplying each one by 4, or you can factor out a 4. So if you add all of this up, you should get 253.2. So then the second question asks, explain the meaning in your answers in terms of the water flow. So since this is gallons per hour, remember when we're usually doing this, we were doing with velocity, especially on your project, you graph velocity versus time or velocities per hour, miles per hour, and you always got miles, which is total distance traveled. So in this one, since you have gallons per hour, you're going to have 253.2 gallons. So what this means is that in a 24-hour period, right, from 0 to 24, in a 24-hour period, 253.2 gallons flowed out of the pipe. So that's the meaning of it. In a 24-hour period, 253.2 gallons flowed out of the pipe. Number 13, a particle moves along the coordinate axis. Its position at time t is the integral from 0 to t of v of x, where v is a function whose graph is shown below. So we're given the graph of the velocity, so we know the graph of the derivative. A says, where is the particle at t equals 0? So this is my position. So s of 0 is going to be from 0 to 0. So my velocity, I'm not going anywhere, or my position would be at 0. Part B says, where is the particle when t is 3? So I'm going from 0 to 3. So where am I when t is 3? That means find the total distance under the curve from 0 to 3. Remember, anything below the x-axis is negative. Anything above the x-axis is positive. So this is a triangle with base 2. The height is also 2, divided by 2, and it's going to be negative because it's below the x-axis. The second is also a triangle with base and height of 1, divided by 2. So I'm at negative 1 and 1/2. So that means I'm 1.5 units to the left. Part C is what is the particle's velocity at t equals 4? So you kind of have to be careful because part C is a trick question. It says where's the particle's velocity? Not where is its position, but what is its velocity? So remember, we're looking at the graph of the velocity. So at t equals 4, my velocity is 3. So when t equals 4, my velocity is 3. So it would be 3 feet per second. For number 10, we're going to evaluate the limit. So notice as I substitute infinity, if you look at the graph of ln, as x goes to infinity, the y value is also going to infinity. And then x squared is just infinity. So we have indeterminate form, so we can use L'Hopital's rule. So I'm going to write this as 1 over x over 2x which is 1 over 2x squared. And the limit as x goes to infinity of 1 over 2x squared would be 0. This is a really huge number, so 1 divided by a really big number goes to 0. For b, I also have infinity over infinity, so indeterminate form, so I'm going to use L'Hopital's rule. Okay, I still have indeterminate form, so I'm going to use L'Hopital's rule one more time. And then this would just go to infinity, because e to the x, the graph, does not converge. So we're going to determine whether the improper integral converges or diverges. So I'm going to rewrite this as the limit as b goes to infinity so the antiderivative would give me 5x to the negative 2 divided by negative 2, and I'm going from 1 to b. So I'm going to have negative 5 2b squared minus so this is going to go to 0 as b goes to infinity because this becomes a really big number. So I'm just left with 5/2. For the second one, same thing. I'm going to do the limit as b goes to infinity. So in order to take the antiderivative of this, I'm going to have to use integration by parts. So I'm going to have negative 3x e to the negative x minus 3e to the negative x. The limit as b goes to infinity, and I'm going from 0 to b. So if I substitute the b, substitute the 0, so this is as b goes to infinity, I have an indeterminate form. So I'm going to rewrite this as negative 3b over e to the b. So this is infinity over infinity, so I can use L'Hopital's rule. And as b goes to infinity, this goes to a really huge number. So negative 3 over a huge number is just negative 3. So I can again rewrite this. So as b goes to infinity, this goes to 0. Sorry. Negative 3 over a really big number goes to 0. So negative 3 over a really big number goes to 0. Okay, so this is 0. This is 1, 3, and a negative times a negative makes a positive. So this converges, and it converges to 3. And then go ahead and skip part C. We're not going to do that.